We think of our world as filled with stuff, like buildings and cars, buses and people. And nowhere does that seem more apparent than in a crowded city like New York. Yet, all around the stuff that makes up our everyday world is something just as important, but far more mysterious. The space in which all this stuff exists. To get a feel for what I'm talking about, let's stop for a moment and imagine. What if you took all this stuff away? I mean all of it. The people, the cars and buildings, and not just the stuff here on Earth, but the Earth itself. What if you took away all the planets, stars, and galaxies, and not just the big stuff, but tiny things down to the very last atoms of gas and dust? What if you took it all away? What would be left? Most of us would say nothing, and we'd be right. But strangely, we'd also be wrong. What's left is empty space, and as it turns out, empty space is not nothing. It's something. Something with hidden characteristics as real as all the stuff in our everyday lives. In fact, space is so real, it can bend. Space can twist. And it can ripple. So real that empty space itself helps shape everything in the world around us and forms the very fabric of the cosmos.
Well, you can't understand anything about the world unless you understand space, because that's the world. The world's space with stuff in it.
We're not usually very conscious of space. But then again, I tell people fish are probably not conscious of water either. They're in it all the time.
Space is not really nothing. It actually has a lot going on inside.
When most of us picture space, we think of outer space, a place that's far, far away. But space is actually everywhere. You could say it's the most abundant thing in the universe. Even the tiniest of things, like atoms, the basic ingredient in you and me and everything else we see in the world around us, even they are almost entirely empty space. In fact, if you removed all the space inside all the atoms making up the stone, glass, and steel of the Empire State Building, you'd be left with a little lump about the size of a grain of rice, but weighing hundreds of millions of pounds. The rest is only empty space. But what exactly is space? I can show you a picture of Spain, of Napoleon, of my Uncle Harold. But space, it looks like this. Nothing. So how do you make sense of something that looks like nothing?
Why is there space rather than no space? Why is space three-dimensional? Why is space big? We have a lot of room to move around in. How come it's not tiny? We have no consensus about these things.
What is space? We actually still don't really know.
It is one of the deepest mysteries in physics.
The stage. It's an absolutely vital part of the show, and yet most of us, we don't even give it a second thought. But Isaac Newton, he did. This is how the father of modern science pictured space, as an empty stage. To Newton, space was the framework for everything that happens in the cosmos, the arena within which the drama of the universe plays out. And Newton's stage was passive, absolute, eternal, and unchanging. The action couldn't affect the stage, and the stage couldn't affect the action. picturing space in this way, Newton was able to describe the world as no one had ever done before. His unchanging stage allowed him to understand almost all motion we can see around us, yielding laws that can predict everything from the way apples fall from trees to the path the Earth takes around the sun. These laws worked so well that we still use them for the things we do today, from launching satellites to landing airplanes. And the laws all hinge on one radical idea: space is real. Even though you can't see it or smell it or touch it, space is enough of a real physical thing to provide a benchmark for certain kinds of motion, like that skater. Newton would say that when she spins, her arms splay out because she is spinning with respect to something, and that something is space itself.
Philosophers have been debating the nature of space for a very long time. What Newton does is change the terms of the debate. And with that, essentially modern science gets born.
Newton's stage was a huge hit. It enjoyed the limelight for over 200 years. But in the early decades of the 20th century, a new set of ideas emerged that shook Newton's stage to its very foundation. Ideas put forward by a young clerk working in a Swiss patent office. His name? Albert Einstein. And in the hands of Albert Einstein, this new picture of space would solve a deep mystery having to do with the most familiar force in the cosmos: gravity. Newton knew that gravity is a force that attracts objects to each other, and his laws predicted the strength of this force with fantastic precision. But how does gravity actually work? How does the Earth pull on the moon across hundreds of thousands of miles of empty space? They behave as if they're connected by some kind of invisible rope. But everyone knew that wasn't true. And Newton's laws provided no explanation. After puzzling over this problem for more than 10 years, Einstein reached a startling conclusion. The secret to gravity lay in the nature of space-time. It was even more flexible than he had previously realized. It could stretch like an actual fabric. This was a truly radical break from Newton. Think of this table as space-time, and think of these balls as objects in space. Now, if space-time were nice and flat, like the surface of this table, objects would travel in straight lines. But if space is like a fabric that can stretch and bend, well, this may seem a little strange. But watch what happens if I put something heavy on the stretchy space-time fabric. Now, if I take my shot again, the ball travels along an indentation in the fabric that the heavier object creates. And this, Einstein realized, is how gravity actually works. It's the warping of space-time caused by the objects within it. In other words, gravity is the shape of space-time itself. The moon is kept in orbit not because it's pulled to the Earth by some mysterious force, but rather because it rolls along a curve in the space-time fabric that the Earth creates.
With Einstein, space became not only real, but flexible. So suddenly space had properties, suddenly space had curvature, suddenly space had a flexible kind of geometry, almost like a rubber sheet.
It opens up a whole new way of thinking about reality that describes the entire universe. Einstein becomes Einstein because of that observation.
Where Newton saw space as passive, Einstein saw it as dynamic. It's interwoven with time, and it dictates how things move. So, after Einstein, space can no longer be thought of as a static stage. It's an actor, and it plays a leading role in the cosmic drama.